So, ladies and gentlemen, hello and welcome to our webinar titled Smart H2 Sensor Technology for the Hydrogen Economy. My name is Dr. Nauman bin Tanveer, and I'm the product manager for gas sensors at Angst+Pfister Sensors and Power. I will be your host and moderator for today's webinar, and joining me today is our guest and speaker, Mr. Pedro Navarro from H2 Scan. So, Pedro, hello and welcome from my side, and maybe you can say some words and introduce yourself to our audience.
Thank you, Naman, and thank you to Angst+Pfister to organize this webinar. My name is Pedro Navarro. I'm the Business Development Manager for H2 Scan in Europe. I have more than 25 years of experience in process analytical business, and I hope you enjoy this information we provide. Thank you.
Thank you, Pedro. Let us then move towards the main content of the webinar. And just for information, after the webinar, we will have the 10 minutes of question and answer session. So we look forward to receive your feedback and questions. And at the same time, you will also receive information and contact details. So if you have any questions afterwards, you are always welcome to come back to us on it. With that said, let's move towards the main content. Hello, and again, welcome to our webinar titled Smart H2 Sensor Technology for the Hydrogen Economy. Let's start with the agenda for today's webinar. In the beginning, I will give you all a brief introduction to both Angst+Pfister and H2 Scan as a company. In the next step, I will introduce you all to the topic of hydrogen economy and the role of hydrogen sensing along with its importance for the realization of hydrogen economy. Afterwards, Pedro will introduce you to some of the most common application areas for hydrogen sensing, which will be followed by an overview of H2 Scan's portfolio with which we can support you in your hydrogen sensing application. And lastly, as mentioned before, we will have 10 minutes of Q&A session where you can ask directly your application related questions. With that said, let's move towards the introduction. Angst+Pfister Group is more than 100-year-old company. It was founded in 1920 and it has become one of the leading global supplier of technical components and customized solutions. Our main areas of competence lies in the field of industrial sealing, anti-vibration, fluid handling, mechanical drives, engineering plastics, and last but not the least, sensors and power technology. Angst+Pfister Group maintains a very strong global presence with operation in over 50 countries spread all over the world. With such a vast footprint, the company employs more than 1,200 employees with its headquarters based in Zurich, Switzerland, which serves more than 20,000 customers all over the world. Our extensive network of employees and worldwide presence enables us to provide localized support, rapid delivery, and tailor-made solutions to our clients all over the world. Subsequently, Angst+Pfister Sensors and Power Group is a distinguished leader in providing innovative sensor solutions and power transmission components for a wide range of industries all over the world. Our group is mainly divided into three business segments, among which today we will be mainly focusing on the gas sensor business segment. After introducing Angst+Pfister Sensors and Power, let's move towards H2 Scan. H2 Scan was founded in 2002 and it's headquartered based in Valencia, California in the US. With more than 20 years of experience, H2 Scan specializes in industrial hydrogen sensing solutions along with safety expertise based on licensed and patented technology. The sensors produced by H2 Scan are based on solid-state technology with offerings such as no cross-sensitivity to other gases, no consumables resulting in enhanced long-term stability, and no maintenance or calibration requirement because of unique auto-calibration feature. Today, H2Scan holds global leading position in hydrogen sensing for many different application areas that plays an important role in the promotion of hydrogen economy. With that said, now let's move towards understanding the hydrogen economy and also the role of hydrogen sensing towards the support of hydrogen economy. When we use the name hydrogen economy, the first question that comes in mind is that what exactly does it mean? So what is hydrogen economy? The hydrogen economy refers to an energy system where hydrogen is the primary energy carrier. The goal of hydrogen economy is to use hydrogen to help decarbonize the energy supply chains. This also includes all kind of power generation for industrial and consumer usage with a goal to replace or complement fossil fuels. With this approach, we can essentially support reduction of greenhouse emissions and promote sustainability. In addition, the hydrogen economy is poised for rapid growth due to strong global investments and strong push towards sustainable energy. Now, after understanding hydrogen economy, the next question that arises in mind is that how can we actually realize hydrogen economy? And to answer this, I can tell you there are many theories behind this, but this will mainly be performed through hydrogen generation systems such as electrolyzer that converts water into hydrogen for smart energy storage and subsequent conversion back into electricity using a fuel cell, turbine or some other means. This can also be distributed through pipelines for industrial uses, home heating, and even as transportation fuel. The next question that arises with this explanation is that what is the role then of hydrogen sensing in hydrogen economy? There are mainly 2 points to consider in order to answer this question. First, hydrogen is needed to control the hydrogen generation process. This also includes process optimization for hydrogen storage, compression, blending, and transportation. And the second factor is more linked to safety and reliability. It is a precondition of any energy carrier, whether it is a hydrogen blending facility enclosure, a pipeline, or even a home environment, to detect the presence and buildup of hydrogen. This is a very important factor that needs to be considered critical when it comes to safety and reliability. So, to summarize, we can clearly say that hydrogen sensor is playing the most critical role during the hydrogen generation process and additionally for the safety aspects of hydrogen as a power source. Now, the last question that comes in mind after understanding the hydrogen economy and the role of hydrogen sensing for hydrogen economy is that what are the challenges in order to achieve this goal? Here, in order to answer this question, we need to understand the physical and the chemical nature of hydrogen as a molecule. So, hydrogen is the lightest and the most abundant element in the universe, and one could think that developing a hydrogen sensor would be a simple strategy. But unfortunately, this is not the case, and it took many years of research and development from the early days till reaching the actual state of art in today's world. The first sensor of the modern age was developed over 100 years ago, and the design using catalytic bead technology essentially measured the heat created by the presence of combustible gases in the air. This approach worked for safety applications but is not selective to hydrogen since it would measure the presence of also other combustible gases present in the environment. This technology, however, is still used today along with a range of new gas sensor technologies developed over the last 100 years. Another very common sensing technology used in the space of hydrogen sensing is taking the advantage of the exceptionally high specific heat capacity of hydrogen by measuring its difference to other gases' thermal conductivity. This is also a good way to detect hydrogen, but this can only work under binary gas mixtures. If background gases are not kept constant, this will result in a large cross interference and eventually unreliable hydrogen detection. So, to summarize this topic of hydrogen economy and hydrogen sensing, we can conclude that a smart hydrogen sensing technology, such as offered by H2Scan and Angst+Pfister, should be used to have hydrogen selective detection with stable operation and essentially no regular maintenance requirement. I will now pass the stage to Pedro, who will continue by introducing you to some of the most common hydrogen sensing application areas.
Typical application for hydrogen sensing. Here, we will see where hydrogen is required to be measured in the different industries. Oil and gas and petrochemical is the most common and traditional hydrogen-related industry. The largest hydrogen user today is the oil and gas and petrochemical markets, where hydrogen sensors are used typically for process control, efficiency, optimization, and safety. Two such common applications in that industry are the hydrotreaters, which uses hydrogen to clean the oil, removing impurities, and the hydrocracking, which uses hydrogen to break large hydrocarbon molecules into small and useful ones for fuel production. Both processes uses hydrogen analyzers to ensure efficiency and processing properly the products. Another common application is the steam reforming, where hydrogen is produced from natural gas and must be measured for production efficiency and monitored for leakage, with high selectivity if possible. One of the challenges in the process application is measuring the gas streams that contains multiple other gases in different proportions, such as the recycling gas in a refinery, which can reduce the measurement accuracy if the sensor is not an hydrogen-specific design. Also, the hydrogen sensor requires a fast response time to ensure tight control when concentration levels fluctuate to achieve optimal process control efficiency. Battery room and area monitoring. That's a traditional safety application for hydrogen monitoring. This is another common application for hydrogen sensing, is the area monitor for leak detection of hydrogen concentration in a contained environment. This is important because hydrogen at certain levels can be explosive with a small spark of ignition sources. For example, in data centers and utility, a battery backup system is used to provide instantaneous power prior to the start of a generator or during a power outage. Cost-effective solutions like lead-acid batteries are common and can release hydrogen during recharging, and that must be effectively managed to avoid accumulation. On lithium-ion batteries, hydrogen monitoring is used as an early alarm on an eventual thermal runaway. Another area monitoring application is the hydrogen fuel cell forklift that could potentially leak hydrogen during charge in warehouse. In those applications, hydrogen sensors are fixed in the ceiling to trigger alarms and enable fans to evacuate the gas when hydrogen concentration is near the explosion limit of hydrogen, which is about 4%. A growing application for battery monitoring is also the BESS containers, battery energy storage systems, widely used in a buffer and backup for solar and wind fields. As every BESS battery systems runs on batteries, obviously, it requires hydrogen to monitor and every container for safety purpose. Another application, energy distribution for transformer health monitoring. So high voltage power transformers requires continuous health monitoring. Hydrogen is an early indicator of potential problems. When something goes wrong in a power transformer, the internal temperature rises and in degradation releases hydrogen before it breaks to release other gases. Hydrogen starts dissolved in the oil and is an easier, simple, and less expensive health monitoring than traditional and complex multi-gas dissolved analyzers. Hydrogen is often in combination with moisture for monitoring, finding other possible high voltage transformer failures. It is an expensive solution if comparing with the cost of replacing or repairing a power transformer. Application for mobility. The role of hydrogen sensing in mobility application includes detecting hydrogen leakage in fuel cell vehicles to ensure safety, monitoring hydrogen concentration in feeding the fuel cell system for optimal operation, enhancing fuel cell performance by optimizing parameters such as humidity and nitrogen levels, extending fuel cell lifespan and increasing vehicle range through precise sensing, supporting hydrogen storage and refueling station with reliable leak detection. So every H2 dispenser nowadays includes a leak monitoring site. Preventing hazards by real-time monitoring of hydrogen in heavy hydrogen-powered vehicles, such as trains, cars, buses, and trucks. Another application is the power to gas. So the role of hydrogen sensing in that application includes ensuring safety by detecting hydrogen leakage in electrolyzers, compressors, transport lines, and storage systems, monitoring hydrogen purity during production, and concentration level control at injection on gas grids, optimizing the blending process of hydrogen with natural gas or biomethane for pipeline injection, being sure it is below certain limits, enabling a quick and precise control of hydrogen flow for efficiency, energy conversion, and storage, monitoring the H2 transport pipelines for efficiency and safety purpose, supporting regulatory compliance and preventing operational hazards in power-to-gas facilities. An accurate hydrogen sensing in power-to-gas systems is vital for safety and efficiency and reliable hydrogen integration into the gas infrastructure. And a quick response is often required, and as a plus, the selectivity to detect hydrogen specifically in a mixture with other flammable gas present in natural gas is really essential. Renewable energy is another application for H2 sensing, which plays a crucial role by monitoring hydrogen production via water electrolyzers powered by renewable sources, what we call it the green hydrogen, ensuring safety by detecting hydrogen leakage in storage and transport systems, verify hydrogen purity to optimize downstream energy conversion processes, supporting efficient integration of hydrogen into smart grids and energy storage, enabling a real-time monitoring for system reliability and regulatory compliance. Additionally, as described before, every renewable facility normally includes a BESS containers, battery energy storage systems. They are used as an energy buffer and backup, and every BESS runs on battery, so it requires an hydrogen monitor for safety purposes. That H2 sensing maximizes that environmental and operational benefits of renewable hydrogen energy systems. Overview on hydrogen sensing product portfolio. Hydrogen sensing product portfolio. This is an overview of the hydrogen sensing products portfolio from H2 Scan. We have three families of products providing specific solutions for the most typical and other challenging applications for hydrogen sensing in the industry. One family is covering the online process gas analyzers, instruments made in the way to see hydrogen in a continuous gas stream for process optimization. We call it iOptima. Other family is covering the hydrogen area monitors, instrument made in the way to detect the leakage of hydrogen in the ambient air for safety purpose. We call it high alerta. And finally, we have a third family of instruments for power transformer monitoring. Those are measuring in line the dissolved hydrogen in transformer oil, looking for the asset health. We call it grid scan. Continuing with the hydrogen products portfolio from H2 Scan, we have here three real solution examples with our hydrogen sensing analyzers, transmitters, and monitors with unique features. For the process control efficiency and optimization, as an example, we have here five generation of high optimal product range with instruments connected to a process stream pipe for measuring online and giving a signal back to the control room. Those instruments are just transmitters with no HMI, human machine interface, so no display or keyboard are required. You just power it and get the signal proportional to the hydrogen concentration. Relevant features are our unique hydrogen selective technology with no cross interferences with other gases, no consumables, no moving parts, and a patented auto calibration feature. So, virtually, got no maintenance. Regarding the safety area monitors, as an example, what we have here is again our fifth generation of the high alerta product range, with instruments to be installed in a room ceiling or at the top side of a container, looking for hydrogen leakage into the ambient air, providing a signal with an alarm if hydrogen concentration is above the glow explosion limit, obviously for safety purposes. Again, those instruments are just transmitters with no HMI, and the features here are critical for the application as no one have our unique hydrogen-specific technology with no false alarms with other flammable gases, no consumables with no sensor replacement, and our patented auto-calibration that avoids the need to calibrate every 3 4 months. Finally, we have instruments to monitor the high voltage power transformer's health. Here we have instruments to be installed in a transformer, being in contact with the transformer oil, measuring in line the dissolved hydrogen in the oil along with the oil moisture, temperature, and pressure, all useful and critical parameters to predict internal failures in an important asset like a power transformer. Finalizing the hydrogen product portfolio from H2Scan, we have here three practical examples with our hydrogen-specific analyzers, transmitters, and monitors with real application on field. On the first pictures, there is an example of a real process instrument in a field environment. You can see one of our online process analyzers in blue color integrated in a bypass sampling system where we adapt the process conditions to the analyzer requirements in terms of pressure, flow, temperature, and eventually the wanted presence of dust or condensate. In the next pictures, we show a typical battery room with racks of batteries, and there our instruments are typically located on the room ceiling at the top of each rack to monitor the hydrogen by accumulation if it is a lead acid battery, or the quick release of hydrogen before an eventual thermal runaway if it's lithium acid batteries, in all cases activating a room ventilation and safety measures. Finally, on the third pictures, you will see our monitors attached to a top valve in a big power transformer. Here, it looks for dissolved hydrogen in order to predict potential failures, sending a continuous signal to the control room. Thank you very much for your close attention.
So thank you for listening. Now let's move towards the Q&A session. So please proceed with your questions. And also to mention, if we are not able to answer your questions today, we will come back to you as soon as possible with the answers. So first question that came up just now, Pedro, this is on the lifetime. So what kind of lifetime do we expect from H2 scan sensors?
Um, Thank you, Norman, for the question. So, our sensor element is made of a noble metal alloy and stands for life. So that's we provide 10 years warranty on the sensor element itself. And also we have the experience from different industries that our instrument is still working since almost 20 years. I mean, we say the sensor will stand for life, but it also depends on the maintenance you provide to them.
Next question. Thank you, Pedro. Next question is about the calibration requirements. So how is the calibration requirements for H2 scan products and analyzers?
It is true that Analyzer requires a calibration. So in fact, our previous generation of analyzers, they do require a 2-point calibration. But we
Hmm.
have developed a new generation of transmitter, we call it Gen 5, which we have a unique calibration feature. So if you talk about previous generation of instruments, they do points, but the new generation, they don't require calibration at all.
Pedro, I've lost you for a minute.
Yeah, it looks like uh, now I'm back.
Now you're back. So you were
Okay,
interrupted
sorry, some
by the duration.
IT IT interference. So sorry, excuse me. Go ahead with the next question, please.
Okay, then I proceed with the next question. So, what is the next question is what is the expected maintenance which is needed for the H2 scan sensors generally?
Okay, that's important. So as I said before, we have a unique auto calibration feature. So regular calibration is not required. But on top of that, we don't have any consumable parts. We don't have any moving parts that will require regular adjustment. So theoretically, if the sample is clean, if the sampling system is well designed, there is no maintenance required for our instrument.
Okay, Pedro, I think there are some connection issues, uh, but I'll proceed in any case for the next question. So, uh, the next question is regarding the selectivity to hydrogen. So, during the webinar, it was mentioned that our technology is specific to hydrogen, so it's selective to hydrogen. Can you please a little bit elaborate why this is so?
So we have a unique solid state sensor element. So it's the only available technology in the market which is sensitive only to hydrogen, no matter what the background gas is, and also no matter how complex the gas mixture is. So that's why we've been very successful in replacing alternative technology existing in the market for hydrogen analysis, such as thermal conductivity, which works only for binary gas mixtures. So that's as I said, is we say that it's specific to hydrogen because it's truly seeing hydrogen.
Hmm. Okay. Next question is interesting one. That's more related to the commercial aspect. So, what kind of price range are we talking about on H2 scan products, Pedro?
Yeah, that's funny and and sometimes it's not easy to answer. So it depends itself on the product. So we have different products with different features. So we have simple area monitors that cost much less than other complex online analyzer for our refinery environment, for instance, with the HMI or ATEX certification. So honestly, it's not easy to answer. It really depends on the product itself.
Hmm. Thank you, Pedro. Next question is regarding the output. So, which outputs is generally implemented in the sensor? At which output is the sensor generally available?
As said before, we try to make it simple. So we have different products. We can offer digital Modbus RTU output, but we can also offer analog 4 to 20 milliamps or alarm relay. So it really depends also on the model you choose.
Hmm. Okay, thank you, Pedro. Next question is also regarding application and certification. So, which hazardous area certifications are generally available on the H2 scan products?
Again, depending on the model. So we have safe area instruments, but we have also intrinsically safe certified instruments requiring insulation barriers. and
Mhm.
we have a standalone explosion-proof analyzer, which is mostly demanded on the refinery environment. For the general green hydrogen economy, is most likely intrinsically safe certification which is required.
Good. Last question then, Pedro, from my side, since we are approaching the end. What is the typical solution you offer for the electrolyzer application area? I think this is a more application related and very interesting question.
Yeah, that's correct. The most common and requested solution for the electrolyzer are the measurement of hydrogen in the oxygen stream for safety purpose. So here we have instruments made specifically for that application and dense conditions, so they are measuring within the low explosion limit in a pure oxygen stream. Another demanding application is to measure the hydrogen in the hydrogen stream itself. So that's for efficiency purposes. So instruments are made in the way that they measure hydrogen in the high range, assuring that the purity is always above a certain limit, let's say 95, 98%.
Pedro, we have again lost you for a minute.
I noticed that there are some interference in the connection, but did my answer get okay?
Maybe you can very briefly repeat the answer, and then
Okay.
we will come to an end.
So regarding the electrolyzer application, I said that the most common requested solution from the market is the measurement of hydrogen in the oxygen stream. That's for safety purpose. So, and I said that we have instruments made specifically for that application and those conditions. So they are measuring within the low explosion limit in a pure oxygen stream. Another demanding said that it's measuring hydrogen in the hydrogen stream itself. So, but that for efficiency purposes. So the instruments here are made in the way that they measure hydrogen on the high range, assuring that the purity is always above a certain limit, let's say 96, 98%.
Okay, thank you, Pedro. So with this question, we come to an end to this webinar. So thank you very much for your attention and participation. And I would like to additionally mention that we will be exhibiting at H2 Expo in Hamburg in 2 weeks from now. So you can find me and Pedro along with other colleagues at the exhibition. So please come and visit us in Hamburg. And thank you so much for joining and your attention today. Thank you.
Thank you for listening again. And thank you, Angst+Pfister, for organizing this interesting webinar.
Thank you, Pedro. Thank you. Thank you, everyone. Thank you. Have a nice day. Bye.